Everyone, I'm Wan Lee. I like to investigate statistical properties of beta 1 hat. Beta 1 hat is, of course, estimate of beta 1. Beta 1 hat means slope of the line, right? Let's see. What are the statistical properties of beta 1 hat? In the estimation equation of a simple linear regression model, y hat equal to beta 0 hat plus beta 1 hat x. This is estimated line. Beta 1 hat here is slope. What is slope? Slope indicates how much y increases or decreases when x increases by 1 unit, right? Everybody knows it. And we say y hat is fitted value, okay? Value on the line at x. Using least square method, the estimate of beta 1 is obtained as beta 1 hat like this. Cross product of deviation x and y summation divided by what? Squared deviations, sum of squared deviations. That is the value, estimated value of beta 1. But when we use random variable y instead of a sample value small y, it is denoted like this. Same thing. But difference between them, small y here, estimate, here, capital letter y, random variable y. Then beta 1 hat is estimator of beta 1. Can you distinguish between them? Estimate and estimator. So I explained random variable as capital letter, uppercase letter, and some specific value of x, capital letter, is small x. This is a value. So if you use only this one, then you cannot understand regression analysis. I didn't find out any statistics textbook distinguishing these two parts, these two notations. They just say beta 1 hat like this. I think so. So this is, I think, a very distinct thing in my lecture. Anyway, okay. So beta 1 hat here, this one, random variable, so follows some distribution. Any random variable follows some distribution, right? Beta 1 hat, this one, estimator, follows normal distribution with mean beta 1 and variance, this part, sigma square over summation of squared deviations, like this. It can be proved when you study mathematical statistics. So beta 1 hat is what? Unbiased estimator, since expectation of a beta 1 hat is beta 1. Okay? So I denote beta 1 hat with bold. Okay? Bold. Here, beta 1 is just a beta 1 parameter, but I try to emphasize with bold here. Okay? You understand that? I think a very, very important thing here, as x and capital X and small x. Next, we need to perform hypothesis testing to determine whether the value of beta 1 hat obtained from the sample can be reliably used. Can we use that value of estimate 0.7x plus minus 0.1 y hat? Can you use this value, okay, for report or some other place? So we have to test H naught beta 1 equal to 0 or not. If beta 1 equal to 0, in other words, null hypothesis cannot be rejected, then it is useless. You cannot use this equation, estimated equation, for any place. When H naught is rejected, the value of beta 1 hat can, rejected, then the value of beta 1 hat can be used for your purpose. The test statistic in this case, of course, beta 1 hat, as like we try to test the population mean, some value, or it is not equal, right? We had test statistic x bar at the time, and the x bar follows normal distribution with mean mu, variance sigma square over n by central limit theorem. Okay, remember that kind of a material, then it will be simple. Then the rejection region for H naught obtained as beta 1 hat less than 0 minus T alpha over 2, two-side test. What? Sigma hat, sigma hat over square root this value. Instead of a sigma square here, we need to sigma square hat, right? Sigma square hat we have studied last time. Or beta 1 hat greater than 0, 0 is here, okay, plus T alpha over 2 times sigma hat over square root summation xi minus x bar square. Just like we did testing hypothesis for population mean, right? Example continued. Let's examine whether the linear line, the regression line for number of employees and sales can be reliably used. We obtained the result y hat minus 0.1 plus 0.7x. Okay, can we use this equation? So we test the hypothesis h beta h0 beta 1 equal to 0, bit h1 beta 1 is not equal to 0. T value, we used T distribution here, beta 1 hat divided by this sigma hat over square root summation xi minus x bar square. So the values is 0.7, okay, divided by 0.6055. We obtained the value of sigma hat last time, divided by square root summation. This one is the value of this one is 10, so it's gonna be 3.656. So p-value, what is p-value? We obtain value of t 3.656, then this area and this area, these are p-value. Why? Two-tailed test. So the distribution, T distribution with the degrees of freedom, in this case 3, right? We have data, 5 datas. Number of sample size is 5, n minus 2, 5 minus 2, so degrees of freedom 3. The T distribution is like this, and our value of T 3.656, the p-value will be two-sided area. So what is that? That is 2 times probability of t greater than 6, 3.656 is 0.0354, 0.0354, that p-value. In this case, of course, I calculated this one by computer, okay, p-value here. So at p-value 3.54%, we reject H naught. Is that correct? There is no need to be overly concerned with beta zero hat, because what is beta zero hat? Beta zero hat is just intercept. Intercept is the value at which the line crosses the y-axis when x equal to 0. When x equal to 0 is meaningless. So no employee, number of employee is 0, then what does that mean? What is the sales amount? We don't have to think about that. However, it is included in the regression estimation equation as it is necessary for predicting y at any given value x. I will explain this part next time. Okay? So I like to point out two things that distinguish capital letter and small letter is important. You can see here. If somebody said, okay, beta 1 hat, only this one follows normal distribution, something like that, it is not correct explanation, I think. Okay, this is it today. Thank you. Bye.